So, enthalpy of formation. Oh, and I got to get attendance too, right? Presley's missing. Wednesday, I believe. Okay. So, enthalpy of formation. Enthalpy, as you have seen with this chapter, means heat. Okay. So when we do this, we use typically this delta sign. Delta means change in. Okay. And you'll see that in a lot of different places, not just chemistry, like any kind of physics stuff. You'll see it all over the place. Okay. It's a standard notation for the sciences that when you see that little triangle, it is the Greek symbol for delta. And that's a change in. Okay. So, when you see this little degree sign associated with these terms, that means that it's a standard state. Okay. And a standard state is that we're at 25 degrees Celsius. The room temperature in here is about 25 degrees Celsius. Okay. Typically, when you're running reactions, they're usually about 25 degrees Celsius. So that's why they make these tables based on that. Okay. You'll find when we get into equilibrium that all of that equilibrium stuff is typically at this standard temperature because that's typically what temperature you're going to be running your reactions at. Okay. Now, obviously, if you go to the South Pole and you're doing stuff outside, or you go to the Sahara Desert in the middle of the summer, you're probably not going to be running reactions at those things, but you'll probably not be doing chemistry either. So, yeah, it just makes life easier, okay, to have these standards. And that's what that little prime, they call that prime. That's what that prime symbol means, okay? So you learned about those bond energies and where you had to take apart these molecules in order to figure out, where there's a carbon bond and where there's a carbon hydrogen bond and where there's a double bond and all of that. And you had bonds broken minus bonds formed. Yes? Okay. All right. So here we're going to be using something called enthalpy of formation. So that formation is the formation of one of those substances. So when it was created, and we can take those and actually run those with a reaction. So this is what I was talking about when we were going through the homework before I started the video here. A lot of times they'll do a subscript and go reaction. So when they give you a delta prime H, this is going to be a reaction at standard conditions, which is 1 atm. It's 1 mole, and it's going to be 298 Kelvin. Okay. And you're going to, and sometimes you'll also see a little F down here as well, instead of reaction. So anytime, again, you see that prime, you know that you're working in standard states. So pay attention to that, because if you had to do like a PV equals nRT problem, they may not give you the pressure, okay? They may not give you the temperature, right? But if you see prime here, you know that your pressure is 1 atm and your temperature is 298. So that information was fed to you. It's just fed to you in a little different way. Does that make sense? And they can be a little tricky with stuff like that every once in a while, seeing if you're paying attention to that. All right. So when we do these equations, and these equations are going to come back to you in several different forms. This isn't just for delta H. We will eventually get to delta G, and we will get to delta S as well. And it's the same concept. It's just different stuff that we're putting in there. Okay. So this is going to be delta H prime reaction equals, this symbol here is a Greek symbol. I think it's sigma. And it means to add all of that stuff up. Okay. So all of the delta F's of products minus all the delta F's of the reactants. Okay? And this equation appears on your equation sheet. So you don't have to have it memorized. It's on there. Now, I have given you a variety of different places that you can go to for these. If you look, I think in your packet there, if you go back a couple sheets, there's a, no, come forward a couple sheets then. Okay. Yes. Yep. See all the tables there? Yep. Okay. So these are those tables that I have copied in there. Notice that there's a delta F, there's a delta G, and there's a delta S. Okay. Right now, we're going to be concerned with the delta F. We will eventually get to these as well, and we combine them all together and use them all at the same time. So make sure that you keep this part of your packet for 6, because when we get to 9, you're going to need this stuff again. Okay. Now, notice on here, when you have a pure substance, its delta H is always 0. Okay. And you'll see these multiple tables here. They just kind of keep going and going and going. But you'll see this, the original stuff, when it's just an element, its delta H is 0. Delta G is as well, which we'll eventually get to. But then your S is a little bit of a stickler. There's always an S. Value. And we'll talk about those two, like I said, when we get to that point. All right. Wow. I'm rocking this cough. All right. So we have the combustion of propane. And we want to know if that is exothermic or endothermic. You can probably already figure that out because it's propane. You know, propane gives off heat when you do it, but so first of all, you need to know what the formula for propane is. So C3H8. We are going through combustion, so what else do we need there? Oxygen. And we are going to go through complete combustion. So our products are going to be CO2 and H2O. Step 1. It's always our step 1 here. Balance that equation. I've got an odd amount of carbon, so I'm just going to go and start balancing my carbon. Then I balance my hydrogen. I've got 8 here. I need 8 on this side. Then I go back and I balance my oxygens. I've got 6 here and 4 here. So that gives me a total of 10. Wow. All right, now we have to go to our tables. One of the things about those tables that you've got to be very careful with, and I find myself screwing this up quite often. So I have tried to tell myself, you've got to be careful here, okay? One of the things that you have to pay attention to in that table is you have to pay attention to your states of matter, okay? So if I go back to those tables and I'm going to be trying to find C3H8, here's carbon. On that page. On that page. Boy, these are not great diagrams, are they? Sorry, guys. Did I miss it on that page? It's on this one.
Yeah.
C4, C3. Huh. Yeah, your copy might be better than mine. I'm gonna hit this and then it's gonna go.
Hang on, Lovey. It's
Yeah, it didn't change. Cool.
Okay, yeah, I see. Yeah, I see it. It's this one.
Okay, right there. All right. Thank you. Okay. So so there's that one. So that's a negative 103.85. Okay. So we're gonna go and put that. So that's my delta H for this guy. Okay. So I'm going to go and put that underneath that one right here, just so I can keep track of it. So we got to look up all these. Okay. And that's kilojoules. All right. Now, this is O2. And if we go and we find our oxygen here, nitrogen, phosphorus. Yeah, it's going to be 0, but I wanted to show them that. Yeah, here's oxygen, okay? So here is O2, okay? And notice that's our oxygen. That's going to be zeros, okay?
Why is the O gas?
Because this naturally occurs as O2. This is a diatomic molecule. In order to get this, you're going to have to put in some energy because you're going to have to essentially break that bond between those two oxygens. Okay. Okay, so our next thing, without having to flip back, since we can remember 0 on our head for that one, let's see if we can find our CO2 here. Here's our carbon. And you guys might be better at spotting this than I am.
Top right. If you go back.
This one?
Yeah.
Oh, here we go. Yeah. So here's our CO2. And notice here that CO2 has a gas and it has an aqueous form. So this is what I was talking about. You have to be very careful with these to make sure that you're grabbing the right value. Because otherwise, you'll just see CO2 and just grab whichever one your eye hits first. Okay? So you got to be kind of trained to override that, grab and go tendency. Okay? So make sure that you're picking the right one. So this is what we want. We want negative 393.5. So I'm going to go back and write that in. I still have it in my brain, in my buffer. This one was a 0. Seriously, are we going to start this morning?
If it makes you feel any better, your board didn't like Shram last week either.
Oh, it doesn't like anybody. It's such a brat. Okay. All right, so now let's try to find water. And this is the one that I goof all the time, you guys, because there's a bunch of different options for water out there. So let's see if we can find that somewhere here. Is that under oxygen?
Go back.
It's under oxygen.
Oh,
Yeah,
one
it
more
is.
back. There.
Up the top.
Top right.
Yeah. So do you see how there's like 3 different things here for water? It's kind of a pain. So you got to make sure that you're picking the right one. And this one they said was gas. And I cannot tell you how many problems I have done over the years where I have gone to check the answer key and gotten a different answer. I'm like, what did I do? I didn't do anything wrong. This is what I did wrong. I grabbed the wrong, I would grab the liquid instead of the gas, and then your values are off. And you're not off by a huge amount. So then you're like, okay, did I just mess my math up? No, I grabbed the wrong figure. So 2418. That was a negative, yes? Did I grab that's what I said. Okay. All right. So everybody good with that? Sir?
Why are there 2 different liquid and gas waters?
The second one, is it this one here? Because that's hydrogen peroxide.
Oh,
Yeah, I'm telling you guys, they're tiny, tiny little things, and they're just little bitty differences between them, and it's real easy to grab the wrong stuff. Now, luckily for you guys, when you take the tests, they're not going to give you these big, huge charts. They're going to give you like 5 things, you know, because they don't have enough room in that booklet to like publish all these charts. But you know, when you get into college, you may be subjected to, so that's why I like to try to show you, you know, kind of the different examples of how these things are presented. Make sense? All right. So now what do we do with this? Well, we're going to go back to that, that formula that we had, which was delta H prime reaction equals, we've got our sigma, delta H prime products minus our delta H prime reactants. Okay. So we got to start with our product. So we're going to start with this side. So be careful because you always want to go from left to right because that's how we read.
Yeah.
Okay. So just be a little careful with that because that's an easy way to kind of flip stuff around. All right. So we have 2 products here. Our first product is going to be negative 393.5, but we have to multiply that by how much we have. Okay. So we've got to go back and look at the stoichiometry here. So I've got 3 moles of that. And then I'm going to add my negative 241.8 times 4. And then I'm going to subtract negative 103.5 for this guy. And I don't need to multiply it by anything because its coefficient is 1. All right, so if you get that in your calculator, I want to try it. All right, is it endothermic or exothermic? Yeah, it makes sense because it's propane, right? You're going to get heat from that when it burns. Yeah.
So our last unit was on bond enthalpies. Is that basically like, can you get the same answer doing those, or like, how would you know which one to use? Would it just be based on the chart they give you?
Yeah, it's based on the chart they give you and also what they're asking. Okay. So if they're asking for heat of formation, you're going to do this. If they're asking for bond enthalpies, you're going to do the other one. And it is confusing. I will give you that.
How do you know this one's asking for heat formation?
Because this is the unit we're on.
Why is the if that side's products and the other one's reactants, why is we minusing the H2O?
Minusing the H2O. I mean,
You just add up everything on the right side and then subtract the sum of everything on the left. That's all you do.
But then shouldn't we minus the 103.5? Oh, it's all in parentheses. I didn't see that.
all right, see if you can do the next one. Although you may not be able to. Well, you should be able to at least get the first part done, right? So figure out the delta H for that reaction. And then I'll show you how to do the next part. I'll do the 7 grams with you, okay? Yeah. Yep. Very good. Yep, you found the right one. And you should have the CO2 and the H2O from the last problem. You don't even need to look those up.
Together times their
Yeah, I down.
And that should.
Oh my goodness. Yes. H2O3 gas. Solid.
Did y'all get this?
Oh. Oh wait, is that the 7-gram one or what? No, wait.
No, that's not the 7-gram one.
Wait a minute. Jack, he's not cooking. Jack, he's just not lost. I'm scared.
So like, is this what you did? Yeah. Okay, so then if I were to name
I got that listing.
yeah, minus this.
Yeah. It's just I get this.
Yeah. What? Get it? Strong, Andrew.
I noticed. Yeah.
I wrote down more.
You wrote down. Yeah, I told you, like, it is easy. It is so easy, you guys, to like pull the wrong value.
I was like, oh, I put a.
Yeah. No, I'm telling you, like, it is super easy.
Way too big. Approximately.
Yeah.
Way too big. Approximately 7 times larger than I should.
All right, everybody up with me getting that value? Endothermic or exothermic? Endothermic, right. Positive value, endothermic. Okay. How is this going to feel if this was in your hand when this was happening and you were able to feel the outside of the beaker? How's it going to feel to you? Cold, right? Yep. Because it's taking heat from the environment and pulling it in. Yep. It's the opposite. But if you think about like propane, right? That was an exothermic reaction. And you know when propane burns, like you've been around a propane grill and stuff like that, right? You know it gives off heat. Yeah? Okay? That's a negative value. It's going to give off. I know. It's mind-blowing.
Every time I turn on the grill, it suddenly gets freezing cold.
I know. It's weird, isn't it? All right. So you ready for me to go through the next step, which is just basic stoichiometry. Everybody loves stoic, right? Yeah. Not stoic. It's not stoic. I'm sorry, I lied. Dimensional analysis.
Okay.
Oh no.
This is so slow.
It's the ladder. It's the sideways ladder. All right, I've got my 7 grams here. of this material. I want to get that into a usable form, which is moles. How do I get between grams and moles? Where do I go? Periodic table, right. So I'm going to take a sodium at 23, a hydrogen at 1, a carbon at 12, and 3 oxygens at 48. I'm going to add them together. All that adds up to be 84.0 grams and 1 mole. Good? All right. Now, and that's moles of NaHCO3. I got it just skinny enough to get it in there. All right. I know based on my stoichiometry that for this reaction, for every mole of reaction that I'm going to generate every time I run through this, okay, I'm going to need 2 moles of this guy. So I'm going to get rid of that. So 2 moles of NaHCO3 for every 1 mole of reaction. Every time I run through that process, I'm going to need 2 moles of this. Okay. I also know that for every 1